Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright, today what I'm going to do is I'm going to do another test on this Class D amplifier, this audio amplifier. It's a 150 watt by 150 watt amplifier, and it has GaN FETs from EPC, Efficient Power Conversion, on here. Really amazing FETs. This board, in fact, was loaned to me by them. So I'm going to do this video, and I think one more where I'm going to play some music, kind of the final test. But you know what? You might be asking, hey, I've seen the series, I've seen the distortion test. This one's going to be different. And now let me just go through the series. The first one we did gain phase, right? We looked at that, see how flat it was and all that stuff. And we went through the test setup and everything. So go look at that video for details of that and looking close at the board and the schematic. We did all that stuff. In the second video we did distortion. You're right, we did distortion, and we looked at fixed frequencies, and I also swept the frequency. I think it took 10 seconds to go across the screen, across the audio band, so that we could see if we could see any weirdness happen. And then the third test, we actually used this thermal camera to see how hot these things got when we ran it at 150 watts. And I'll tell you what, the resistors got really hot. Amplifiers, not so much. Kind of amazing. They don't need a heatsink like this. You might want to put one on it just to make it look cool, but but it actually operates really cool without a heatsink. So really amazing. Alright, so I was going to do an audio test, but you know, there's some folks that wanted to see intermodulation distortion. I think it was Bert that mentioned that, and you know, that's a test I've kind of played around with, and so I thought, yeah, let's add that to this test. Now, what that test is putting more than one frequency in the amplifier at one time. Well, music puts lots of frequencies in, right? Well, there's a group of guys that found out that if you put two frequencies into an amplifier, sometimes you just saw some weird things happen. And that was kind of gave you a good idea of what would happen when you actually put real music into the amplifier. So it was a Society of Motion Picture and Television Engineers who found out that if you put, like, let's say a low frequency and a high frequency into the amplifier at the same time, they would modulate on each other, and some other frequencies might appear if you had non-linearities in your amplifier. So it was a good way to check to see if the amplifier is linear. What you should see is just those two frequencies in your spectrum, you know. And alright, so let me just give you a kind of an example that you can maybe think about. Have you jumped on a trampoline with a friend? If you both jump together, you go higher, right? Now, if one of you kind of get out of sync with the other guy, then it starts getting weird, right? You start getting weird frequencies, basically. So, but if one person jumps, and then maybe they jump off on the border of the mat, and then they jump over on the trampoline with you, maybe on the second or third jump, every other jump. As long as they hit it right when you hit it, it's nice clean bounces, right? It's kind of like the frequency of the mat is going, you know, linear, it's consistent. But if they're off timing a little bit, then it kind of causes perturbations or, you know, unwanted frequencies. So that's kind of a way to think about it. So if your amplifier has some non-linearities, you know, we're going to see that when we try different frequencies. So that's why we're going to try different combinations. And let's look at this for a moment. So here we go. You can see this low frequency, and you can see the high frequency. Well, this is in the scope, or in the time domain, right? In the frequency domain, this low frequency will be a little spike over here, and the high frequency will be a spike over here. Now, what they found out was that if you put kind of a 4-to-1 ratio, 4 times in the low frequency amplitude as you do in the high frequency, then that was what they thought worked best. And they used, I think, 60 hertz and 7 kilohertz for a reason. I think they chose 60 hertz because in the US 60 hertz is our power. I think that's why they use that. 7 kilohertz, I think they chose that because And I think at one time it was 6 kilohertz, and I think it changed to 7 kilohertz. I've tried both ways. I don't really see a difference doing it either way. But I think the idea is that 7 kilohertz is where your ear's fairly sensitive. Most of us have pretty good hearing around that frequency, and I think they felt that if you have distortions around that frequency, you could hear it. So what happens is you'll get, if you do get distortions, sometimes it'll be the addition of the two frequencies. So you'd see the 7 kilohertz with a 60 hertz spike on this side and a 60 hertz spike on this side, or 2 times that frequency. Say minus 120 hertz on one side and plus 120 hertz on the other side. So you'd see these little side bands, they call them. Yeah, you don't want that. You just want one spike and that's it. Okay? So, and one of the ways they measured that was that if you saw those side bands, then they had to be so many dBs lower than your amplitude of your main signal, that your the center signal, okay? Because if they're below, I think it was 40 dBs, they felt like you're not going to hear that. So I think it was 40 dBs was kind of like their point where they said you should be below that. Well, what we're going to do is we're going to look at those two frequencies. We're also going to look at another test that someone came up with where they did 6 kilohertz and 7 kilohertz, and in that case they just put the same amplitude, okay? And then another test was 18 kilohertz and 19 kilohertz. So I think we're going to have time to do all three. So we're going to kind of go through them kind of quick. I think the first one will take a little more time. The second two, probably try to speed it up. All right. So, hey, let's jump over here and do it. But before, subscribe if you haven't done so, okay? And also like the video. Remember to like the video if you like it, because that really does help. So comment, give me ideas, what you guys think. I've got some Class A Bs, some Class Ds, some other Class Ds without GaNs. And then I have some Class A's I got to build up. We're going to test those. And by the way, as soon as I do the next one with the music, I think I'm going to do a crossover. I've got a new crossover. So we're going to do that. And I've got some interesting stuff to do on this crossover. So, and then we got to get some power supplies, right? Okay, so hey guys, let's jump over and take a look and see what we see. Let's do it. Okay, so just a quick overview of the scope setup. On channel 2, I have I'm looking at the output of the amplifier with the Mixig DP10013, and it's set at times 50, and it's powered by this USB. I'm looking at the input signal channel 4. Okay, so let's just go look at that real quick. Here's the scope screen. The output right here is in green. Looks kind of fuzzy. I'll show you why. Let's see, if I pull out on this a little bit, got to get the zoom. Got to get the trigger right here. Whoops. Let me get a different coupling. Let's try that. High frequency reject. Okay, you see that right there? That's a high frequency signal riding on top of this low frequency. Okay, now let's go look to see what we did. But first, channel 2 is 50X, and it's DC coupled, 1 meg ground, and channel 4 is 10X. The scope probe's in 10X position. Okay, so now, right now, it's showing about 60 hertz. Okay, so now let me show you where this guy's coming from. If I go to my options here, my generator 1, sine wave, settings 60 hertz, and 2 volts peak to peak. So then let's go back, and go back again to generator 2. Sine wave waveform settings 7 kilohertz, 250 millivolts peak to peak. So it's a fourth of the voltage of the other channel. So I go back and output setup. Output generators 2 is on. We saw that they're both on, right? Let's go to 1. See, they're both on. They're both set at low impedance. And okay, phase is 0 on both, I believe. Let's make sure. Yep. Okay, so we're good there. Going back here, channel 2, the blue one, is the output. I'll just bring it up so you can kind of see what it looks like. There we go. Now, if you look at the output, look at that. It's got that 7 kilohertz frequency riding on top of it. So we're modulating the signals against each other. Pretty cool. I'm going to turn it down for now, and we'll go back to spectrum. Spectrum analyzer. Now the source is channel 2, so that's the output. So if we go to channel 4, we can see what our input looks like. And there's our signal. There's a 7 kilohertz signal, and there's a 60 hertz signal. So that's the input signal. Otherwise, the noise floor, that's 40 dB, that's 60. It's about 70 dB down here. That's pretty darn low. So this is sitting at about -20, and this guy's almost 0. Okay, and then we we go channel 2 again, so we can look at our output. Right now the volume's turned all the way down, so no signal. That's what we'd expect. Noise floor again is about 50 now, okay, on the output. So now let's go ahead and bring up the signal. There we go. Now what I'm looking for is, I'm going to take this up to about 20 dB, I think. Well, we'll go a little bit higher than that. Okay, we're about, what does it say? So the pointer is right here, the green guy, and right there. Let me bring the camera over. Okay, the pointer's up here. Down here it says 60 hertz is about 28 dBs. Okay, and then 7 kilohertz is over here. Now what we want to do is we want to focus on this guy to see what kind of sidebands it has. So let's go back to the spectrum and go to frequency and span. And if this is 7, you know what? Let's go to, we can go center and span. Let's do that. Let's go 7K, or we can go start and stop. Let's do it the center idea here. And then we'll go up to 7K, put that 7K right in the center of the screen. See, it's right in the center now. Okay, then we'll go back, and let's say the span is 2K. So I have 1 kilohertz on either side of it. Okay, that's 2 right there. Okay. And I'm just looking, I don't see anything. Let's get this guy out of the way. So I see this guy, you see my little green arrows up here, and now it's saying 7K 9.6 dB, but I don't see any sidebands here. Let's go to bandwidth. Here's our 5K, that's set maxed out. Okay, if I turn it down, yeah, right, okay, right down here. Okay, so it says 1 hertz here is our bandwidth. That's our resolution bandwidth. And now look, we're set at 10 dBs per decibel, and I really don't see a lot. We're down here minus 40 dB, and the signal is up here at 10 dB. So we're about 50 dB signal to noise ratio to the peaks. Let me, okay, let's go back to amplitude. Let's go to 20 dB so we can get it on the screen. Alright, what do you guys think? Okay, so this is 7K and this is 8K. So there's 1 kilohertz between here. So this is 250 hertz, 500 hertz. So 250, 60 hertz should be right down in here. Now, you know what? Let me try spreading that out a little bit more. Let's go back to frequency and span. Let's go to 1 kilohertz instead. Okay. So now this is 750, 7.5 kilohertz, and this is 6.5 kilohertz. You can kind of see 7.5 up here and 6.5 there. Jeez, guys, I still don't see anything. So this is 7100 hertz. We should see a 60 hertz sideband there if there was going to be one. There one would be here, and then there'd be at 120, which there might be one there at 120. But I don't see, yeah, I don't really see it, guys. So what I see is 9.6 dB now. It's kind of changing a little bit, but 9.6 dB there, and these next peaks are right around 40. So about 50 dB from the peak amplitude here to the peak amplitude of some of those noise signals. And the total THD is about 0.8%. Alright guys, so now let's, what I wanted to do is I wanted to go to 6 and 7 kilohertz, and I kind of lost the footage here, so I'm filming this. So generator 1, I just want to show you what I did. I set it for 2 volts peak to peak, 6 kilohertz, okay, that's generator 1. And then we go back, generator 2, sine wave, 7 volts, 2 volts peak to peak, okay? So let's go look at the input signal now. Pretty crazy, right? So look at that. That's our 6 and 7 kilohertz kind of beating on each other. They're modulating with each other. I think that's pretty crazy looking. And I have to see how the trigger's set here at the top. It's a little bit tricky triggering on a signal like that as well, but it's holding pretty solid here. And this guy up here is saying about 1 kilohertz. It's the difference between the two frequencies. I think that's kind of a nutty looking waveform myself. See, this is set for 200 microseconds per division, but yeah, this guy thinks there's 1 kilohertz. So when I set it for 1 millisecond, it should be 1 kilohertz per waveform, but we really have 1, 2, 3, 4, 5, 6, 6 or 7. I think it's interesting how the frequency counter gets totally lost on this waveform. You know what it might be doing is, oh, you know what? That's exactly what it's doing. Look at this. It's picking up the low frequency modulation. See how every grid there's about 1 kilohertz? I want to see what my record length is. Let's go, I'm only at 100 kilohertz. Let's max out at 10 meg. See what difference we get. Yeah, it's about the same. It's a pretty crazy waveform, I think. Okay, let's go to the spectrum and see what that looks like. Well, you know what? Before we do that, what I want to show you is, let's bring up the output. Now, I offset these of a grid so that the peaks would be offset from each other. I'm also going to bring this guy down a little bit to kind of get it out of the way. As I bring up this, okay, I'm going to have to bring this down so you can see it. Right there. You see how the waveform's really starting to get trippy at the top? It's starting to, let me zoom it out a little bit. Okay, now if I'm down here, sine wave, blue sine wave looks pretty true to the green, and my THD meter is saying about 0.6, about 0.3, 0.5, 0.6 down here. And as I turn up, look how that waveform starts to get distorted. Now that's 25, whoops, sorry, that's 50 volts per division. Yikes, no wonder. Now that's 25 volts per division, and my power supply set plus minus 31, about 31 volts. So yeah, that's now up right. Look at that. That's getting distorted. I'm at 2% distortion there. If I go up a little bit higher, 3%. So bring it down, and then I can bring this guy back up. But just bring that down a little bit. We're about 0.4, 0.5% right there. So it's interesting because the THD meter has an automatic setting. I could manually set it for a certain frequency, but right now, maybe I should do that. But right now it's set for automatic, and so it's automatically trying to find whether it's 6 or 7 kilohertz, and it can't decide. So it's kind of bouncing around. And I think that's interesting that it's showing 1 kilohertz. Okay, let's go to the spectrum. Okay, that's kind of interesting. We're seeing some stuff out here. Now this is, by the way, let's look at the bandwidth, frequency, and span. I got start. Here, let's go start at 1 hertz. And stop at 20 kilohertz. Okay, so we're all set up. 1 to 20 kilohertz. So 20K here, 10 hertz here. And so in the middle it's about 10 kilohertz. So there's our 6 and 7 kilohertz right there. And you see the green arrow bouncing between the two? Right here 6, 7 kilohertz. Right here 16.8 dB. That's solid because they're the same amplitude. It's pretty interesting, right? Okay, and so then we have this guy out here around 19 kilohertz. And my THD is about 3.5. Okay, I'm going to drop the amplitude a little bit and see what happens if this guy just disappears. So you can see these guys come down a little bit. I'm at 14.4 dB. Yeah, so this guy looks like it's a function of these two guys pounding on each other. And right about there, 6.4 dB, he's dropped down. So this is 20, 40 dB, you know, 45 dBs down. And if I bring it up, let's see if that guy gets kind of crazy. Okay, let's see these other ones coming up now. And we're about 0.5 THD right now. It's interesting. Okay guys, just real quick, I went and set up the generators for 18 and 19 kilohertz. So look at this, it thinks it's 3 kilohertz, but that's 18 and 19K. I'm just going to save some time, not walk through all that stuff again. But let's go to the spectrum now. And there's the 18 and 19 kilohertz. And we see a little bit of a guy right here. These guys are up around, see the marker right here? It's kind of stuck on the 18. Yeah, no, it's bouncing around 18, 19. About 8 dB. I can take it up a little higher. And as I do, you can see this guy, but now I'm starting to see one over here too. Okay, so this is about 17.6 dB. And this guy here looks like it's about 18 dB. So there's about 36, 40 dB between them maybe. Pretty close, not quite. So bring it down just a little bit. About 14.4 dB. And this guy is sitting right about 20. And these guys are down here close to 4, about 35 probably. Minus 35. So my total THD on my meter is gone total wacko. I got to go to auto. Okay, the THD meter shows about 0.1%. It's only considering that about 0.1. I'll bring it up a little bit higher again. And THD still only about 0.1. Yeah, so those signals are around 20 dB. And these guys, this guy here's, not quite down 20. It's about 18 dB probably. So, yeah, it's kind of interesting, right? Okay, so that resistor is getting pretty toasty, guys. This 200 watt 8 ohm resistor. This is about 17.6 dB on each of those two signals. And you can see the THD's kind of bounced around 0.1, 0.3, so it's 0.13. Not too bad. I'm going to go and crank it down. So what do you think? Hey guys, so what do you think of that? That was pretty cool, I thought. It looked pretty clean to me. And hey, by the way, if you liked the video, thumbs up, share, and subscribe if you haven't done so. All right, so hey, and guys, thanks for the Patreons. Really appreciate it. Got some patrons supporting me. I really appreciate that. Links below. But you know what? I need to do this distortion, these kind of intermodulation distortion tests on these Class A B. I got a Class A amp I'm going to build, and I need to do those tests on those kind of amplifiers too. I've got another Class D over here. I need to pull that back out, kind of finish that design, and have something to compare to, right? Because right now this looks pretty darn good, and this resistor got pretty toasty, and yeah, I like that. I kind of zoomed in on it here, but all right, guys. Hey, thanks. We'll see you next time. Hey, next time I'm gonna hook it up to a speaker and play some music. All right, let's do that next. And then I got to return it. Darn it. But hey, it's been fun. It's been really cool. All right, we'll see you next time.